Eighth question, the number of terms in the expansion of root 5 plus 4th root of 11 power 124 which are integers is. Okay, now whenever you do this kind of a question, what you have to do is you have to try writing the general term. Now if you compare this expression with x plus a power n, we will get x is equal to root 5, a is equal to 4th root of 11 and n is equal to 124. So this is what we get. Now if you substitute here tr plus 1, the formula is ncr x power n minus r a power r. So this is the formula. Now we don't know what is r here. Okay, r is what decides the question actually, the answer for the question. So now n, so other than r will keep it as it is, other than that will substitute everything. So n is 124 cr into x is root 5. Now this root 5 I can write it as 5 power half. So root 5 is 5 power half power 124 minus r into a. Now a is 4th root of 11. Now 4th root of 11 you can write it as 11 power 1 by 4 power r. So this is the general term of the expansion, and now this is 124 cr into, now this is 5 power. Now let me write this in this way. So 124 by 2 we will get 62 minus r by 2. So I will split this and write 124 by 2 minus r by 2. So that will be 62 minus r by 2 into, this can be written as 11 power r by 4. Okay. Now this is the general term of the expansion. Now you have to find that the number of terms in the expansion which are integers. Okay. Now we know whenever we write a binomial theorem, the value of r, now when you start with x plus a power n, the first value of the binomial expansion starts with nc0 x power n, and finally at the end it ends with ncn a power n. That means the value of r can start from 0 and go up to n. So r can take values from 0 up to n. So that is what we know. So in this, the value of r here can start from 0 and it can go up to n. Now n is nothing but 124. So in this question, r can take values from 0 up to 124. Okay. Now when you put r is equal to 0, 1, 2, etc., now you have to see which all terms are integers. So that is very important. Okay. Now you know, see, there are some fractional terms like r by 4 and r by 2. Okay. Now you have to only count those values of r for which these all become integers. Now you can see clearly the first value of this becomes integer when you put r is equal to 0, because when you put r is equal to 0, 124 C0, now NCR is always an integer, there is no need to worry about that. Now when you put r is equal to 0, 0 by 2 is 0, so you will get 5 power 62 which is an integer. When you put r is equal to 0, 0 by 4 is 0, 11 power 0 is 1 which is an integer. So it happens for r is equal to 0. Now it does not happen for r equal to 1. If you put r is equal to 1, we will get 11 power 1 by 4. Now 4th root of 11 is not an integer. Now you can see that the next integer happens when r is equal to 4, because 4 by 2, 2, then it becomes an integer, 4 by 4 is 1. For 2 it does not happen, because 2 by 2 becomes an integer, okay, then 5 power anything becomes integer in that case, but 2 by 4 is half, 11 power half is root 11, so it will not become an integer for r equal to 2. Next integer happens when the value of r is 8, yes, and now you can see this happens, these values becomes integer when the value of r is a multiple of 4. Next it happens for 12, then it happens for 16, and going like that the last value which r can take is 124. Let us check for 124 whether this becomes an integer. 124 by 2 obviously goes, so therefore 5 power that becomes integer. 124 by 4 also, 124 is a multiple of 4, so that also becomes integer. Yeah, there, that means 124. That means for these values of r 0, 4, 8 up to 124, for these values of r, this general term becomes an integer. Now our simple job is how many terms are there which are integers. Now the number of terms which are integers correspond to exactly the number of the numbers which are present here, the number of numbers which are present here. And from 0 to 124, how many numbers are there with a common difference 4? Yes, you can use arithmetic progression formula and find out, or otherwise there is a very easy way. If you want some numbers which are in arithmetic progression, if you want to know how many numbers are there, what you have to do is you have to just subtract the first value with the last value. So you have to do 124 minus 0. So that time you will get 124. Then what you have to do is you have to divide by the common difference. Now common difference is 4. So therefore when you get the common difference you will get 31. And always the answer is 1 more than this. So 31. Therefore from 0 to 124 there are 32 numbers which are integers. Now you can try this for a small value. Suppose you want 0, 4, 8, 12. You know here there are 4 numbers. If you try to use that logic, first you have to do 12 minus 0. So 12 minus 0 is 12. So this you have to divide by the common difference. 0, 4, 8, the common difference is 4. So 12 by 4 becomes 3. But the number of numbers here is not 3, it is 4. See, it is 1, 2, 3, 4. That means for this value you have to add 1. So that is the same logic I have done. 124 minus 0 by 4 is 31. So actual answer is 1 more than that, so 32. So therefore 32 is the correct answer for this question.